Okay, for the given circuit that we have here, the peak voltage across the 50 ohm resistor, we have to find out the voltage across this 50 ohm resistor. It's a RLC circuit that we have done a few times before as well. So the first thing we need to do is to find out the inductive reactance, the capacitive reactance, and then once we have the impedance measured, we can just simply apply voltage divider to find out the voltage across the resistor right here. Okay, so let's get rolling. Let's plug in the values. Omega we know equals to 2 pi f. So 2 pi f is how much? 160. If I plug in the value here, 160, and if I do the math, 2 pi times, so 320 times pi is going to give you 1005. Okay, remember this is radians per second. Then find out the inductive reactance. So again, J omega is 2 pi f, which is basically 1005. So I'll just plug in that 1005, and then inductance value is 0.2 Henry. And if I do the math here, I basically would get J201. And again, remember the J basically tells it's the impedance. Find out the capacitive reactance. So negative J omega we know is 1005, and then let's look at the value for the capacitor. It's 4 microfarad. Okay, so 4 times 10 to the power minus 6, and if I do the math here, I basically get X of C, capacitive reactance, to be negative J 249 ohms. Okay, now that we have calculated these three parameters, we can just simply go in here, apply voltage divider. Remember, our goal is to find out the voltage right here. So peak voltage, well, this is gonna be in RMS right now. The voltage across the resistor is gonna be in RMS because we have this in VRMS. And then, so let's keep it in RMS, and then later on we can convert that into peak voltage. Okay, so 50 here, which is the source voltage, times the value, the resistance value here, which is 50 ohms. And this 50, I'm just going to put it in a polar format, 50 volt, 0 degree. Right? And then 50 is basically this resistance divided by the impedance of this whole network, which is basically a sum of all the resistance. So we have J201, right? 50 plus J201 plus, actually this is going to be negative here, correct? So this is going to be negative J249. Negative J249. So this becomes 250 angle 0 degrees, and then this becomes 50 201 minus 249. 50 minus J48. Let's convert that into polar. So this remains as it is, to 50 comma negative 48. So it's 69.31. 69.31. Angle is how much? 43.8. I just realized that I am missing a 0 here, because 50 times 50 is 2500, not 250. So 2500 here, and then if I divide 2500 by 69.31, 2500 divided by 69.31, I get 36.07. So 36.07, and angle would be 0 minus 43.83, so negative 43.8, right? Okay, now that I have this, remember this is VRMS, so all I need to do is to convert that into V peak. You just have to basically, whatever the VRMS value is, divided by 0.707. So the VRMS value is 36.07. So I'll take 36.07 divided by 0.707 equals to, let's do the math here, 36.07 divided by 0.707. Let's see, what do we get? 51.01. So peak voltage is 51.01 volts, and that is your answer.